Let's begin with the paper 2 JEE Advanced 2016. In this paper we are going to discuss the first question. First question is just related to the modern physics, in which it is discussed that the electrostatic energy of Z protons uniformly distributed through a spherical nucleus of radius r is given by E is equal to 3 by 5 Z into Z minus 1 into E square upon 4 pi epsilon naught into r. The measured masses of neutron, proton, nitrogen, oxygen are given as it is. Now, it is also given in the question the radii of both the nitrogen and oxygen nuclei are same, and one unit is equal to, when AMU, atomic mass unit, is equal to 331.5 electron volt per 6 c square. C is the speed of light, and the value of E square upon 4 pi epsilon naught is equal to 1.44 mega electron volt. Assuming that the difference between the binding energy of nitrogen and oxygen is purely due to electrostatic energy. So we have to find out the radius of either of the nucleus, and it should be in the femtometer. So this question is based on the concept of electrostatic energy, in which the concept of fission take place, in which neutron is bombarded with oxygen, produce nitrogen along with proton. So we are going to write the equation for this, that oxygen 8 neutron is going to bombard, it will produce proton along with nitrogen 15. So we have to calculate the mass effect that will gives us the concept of binding energy. So we can say that binding energy of nitrogen can be calculated as 7 into mass of proton, because there are 7 proton and 8 neutrons, into Mn minus mass of 15 nitrogen 17. Similarly, we would calculate the binding energy for oxygen having atomic mass 15, atomic number 8, and that should be equal to 8 into mass of proton plus 7 into mass of neutron, from this minus mass of 15 oxygen, and that is 18. So on placing the values, we know that binding energy is equal to mass effect into C square. So we are going to calculate delta VE, the binding energy, is equal to mass of neutron plus mass of proton plus mass of oxygen minus mass of nitrogen. Okay. On placing the values, finally we got the answer as the value of mass effect 0.000084 plus 0.002956. Okay, solving this one, we get that this quantity is equal to 0.003796 atomic mass unit. Also, it is given in the question that the electrostatic energy that is given as 3 by 5 Z into Z. Here it is given E is equal to 3 by 5 Z into Z minus 1 E square upon 4 into 4 pi epsilon. So we are given the value of energy. Now we will calculate energy difference for oxygen as well as nitrogen. That is what 3 by 5 oxygen 8 into 8 minus 1 upon 4 pi epsilon, this value, into R. We are given this relation. From this, electron square is also there. This is for oxygen, minus we will calculate for nitrogen 7 into 7 minus 1 into E square divided by 4 pi epsilon. Also we are given the value of 1.4 pi epsilon naught from the question, and then that should be equal to the 0.003796 unit. Solving this relation, finally we will get the value of R as equal to 3.42 into 10 to the power minus 15 meter. That should be equal to 3.42 femtometer. So we use two concepts in this question. First is the difference of electrostatic potential energy occur due to the bombardment of neutron with oxygen produce nitrogen and proton. And using conservation of energy concept here, we got binding energy difference is equal to the energy of potential difference. So that is equal to we got the radius r is equal to 3.42 into 10 to the power minus 15 meter. So this was an easy question. Now we will discuss second question. In second question we are given the the ends Q and R of two thin wires PQ and RS are soldered together. Initially each of the wire has a length of 1 meter at 10 degrees Celsius. Now the end P is maintained at 10 degrees Celsius while the end S is heated and maintained at 400 degrees Celsius. The system is thermally insulated from its surrounding. If the thermal conductivity of the wire PQ is twice that of wire RS and the coefficient of linear thermal expansion of PQ is 1.2 into 10 to the power minus 5 per Kelvin, so we have to find out change in the length of the wire. So in this question is based on law of thermal expansion in heat and thermodynamics chapter. So this question is also easy question, but we need to analyze the concept and its diagram. So we will proceed here. If this is the rod, now there are two ends P, S, and Q and R are joined together. Q and R are joined together. Now it is also given in the question and P is maintained at 10 degrees Celsius and S is maintained at 400 degrees Celsius. Now in this question we have to find out the change in length if they are put in contact. So we need to calculate temperature of the junction, what it should be. We know in the concept of thermal expansion or heat flow, the heat flow through PQ will be equal to heat flow through PS. So similarly we can say the rate of heat transfer that should be equal to dq by dt should be equal to twice of Ka into T minus 10 divided by length L should be equal to Ka into 100 400 minus T divided by length L. Solving this mechanism, finally we got that T is equal to 140 degrees Celsius. So this is the temperature of the junction, that is 140 degree Celsius. Now when the rod PQ is maintained at temperature 10 degrees Celsius and 140 degrees Celsius, so there is a difference of temperature. Definitely there would be change in the length. So we have to find out this change in length. Now change in the length delta L for the rod PQ, we have to find this statement. Now we will analyze let rod PQ is this PQ. We would like to calculate at a distance x. We consider a small element of thickness dx. Now we are going to calculate the temperature gradient. Temperature gradient means delta T by delta x should be equal to temperature difference 140 minus 10 divided by length. Length is given as 1 meter. It is given in the question, that is 1 meter. So on solving this we got it 130 degree. So we got delta T by delta x is equal to 130 degrees Celsius. Now in the second point we know that temperature at a distance, because we want to calculate temperature at a junction or at any point Tx. So Tx can be calculated, that is equal to 10 plus 130 into x. Now we are going to calculate increase in the length of a small element. A small element that is equal to, let we assume it dy by dx. It should be equal to alpha into delta T. This concept is taken from law of thermal expansion. So dy by dx is equal to alpha into delta T. So that must be equal to alpha into T minus 10. Okay, so from this part we will take the final result as dy by dx is equal to alpha into 130 into x. Now we are going to integrate this term dy and the extension is 0 to change in length delta L. That should be equal to 130 into alpha into x into dx, and that is equal to 0 to length L. So finally, solving this mechanism, we got delta L is equal to 78 into 10 to the power minus 5 meter, and that should be equal to 0.78 mm. Hence, in this part, we can say option A is correct. So in this part, option A is the correct choice. So in this question, we use the concept law of thermal expansion, and we calculated the temperature of any point. So we use this concept and get the answer A as a correct choice. Now we will take third question. In third question, an accident in a nuclear laboratory resulted in a deposition of a certain amount of radioactive material of half-life 18 days inside a laboratory. Now, tests revealed that the radiation was 64 times more than the permissible level required for safe operation of the laboratory. What is the minimum number of days after which the laboratory can be considered safe for use? So in this question we will use the concept thermal in this question radioactive disintegration. So now we will calculate an accidental thermal. So from this part we will note down the given data, that is T half is given as 18 days. Tests reveal that radioactive was 64 times more than, it means initial capacity was 64 times of the final amount remains. So we are knowing that activity A is directly proportional to number of atoms in the radioactive disintegration. So from the law of radioactive disintegration we got N is equal to N naught into 1 upon 2 T upon T half. So T half is the data given in the question, that is as 18 days, and T is the total life given. So now we are going to take N upon T half, that is equal to N small n, and N is equal to what? Number of half-lives in average half-life. So we are given if N at any time T is equal to N naught by 64. So from this relation we got N naught into 1 by 2 to the power N, that should be equal to N naught by 64. And just solving this relation we got 1 by 2 to the power N, that should be equal to 1 upon 2 to the power 6. From this relation we got N is equal to 6. Now already we considered N is equal to T upon T half, and T half is equal to 18. Now solving this question we got T is equal to 18 into 6, and that is T is equal to 108 days. So this question is based on radioactive disintegration, in which number of atoms was given at two different instants. We use the law of radioactive disintegration, put the values and get the final answer. This was an easy question. Now we are going to start question number 4. There are two vernier calipers, both of which have 1 centimeter divided into 10 equal divisions on the main scale. The vernier scale of one of the calipers C1 has 10 equal divisions that corresponds to 9 main scale division. This is for C1. Now for C2 it has 10 equal divisions that correspond to 11 main scale division. This is for C2. Now the readings of two calipers are shown in the figure. Measured value. So the measured value in centimeter by caliper C1 and C2. We have to find out the value of C1 and C2 in this question. So this question is taken from the measurement analysis, in which concept of vernier calipers least count main scale division is used. So we will consider here that this is 0.3 it is 3.5. It is also 3.5. So we can say main scale division and this is 1 year scale division. They match at this point 3.5 and 3.5. Okay, so we are going to consider the value at this point. What should be the value? Now we know that for scale reading of the vernier calipers, first of all we will use the formula, that is reading of a vernier calipers is equal to main scale reading plus n into least count. Okay, now for this part we will take for first caliper. For first caliper we are given that vernier scale division, that is VSD, is equal to 9 MSD. So we can say 1 VSD is equal to 9 mm divided by 10. So we got the value as 0.09 centimeter. Similarly, we will take for second caliper. For second caliper, we can say 1 VSD is equal to 11 mm divided by 10, that is equal to 0.11 centimeter. Now we are going to calculate the value or the reading of first caliper. So reading for first caliper, that is equal to R1 should be equal to 3.5. So 3.5 is the point where MSD VSD match. So 3.5 minus, we are going to measure the value of this point. So we will count the values, that is 1, 2, 3, 4, 5, 6, 7. So it is 7 point lagging. So that should be 3.5 into 7 into least count. So what is that? 0.09. Solving this, we got answer is 2.87 for scale 1. Similarly for 2, reading for second caliper, that is equal to 3.5 minus 7 into 0.11, and solving this we got that is 2.83 centimeter. So we use the main concept as vernier scale reading plus main scale reading is equal to reading of the vernier calipers. So this question is very easy, and where we use the concept of least count, vernier scale division, and just we got the answer of here. Question 5. In question 5, a gas is enclosed in a cylinder with a movable friction piston. Its initial thermodynamic states are pressure P1, V1, changes to the final state PV, PF, VF in an adiabatic quasi-static process, such that P to the power 3 V to the power 5 is equal to constant. Consider another thermodynamic process that brings the system from the same initial state to the same final state in 2 steps. An isobaric expansion at P initial followed by an isochoric process at volume V5. So the amount of heat supplied to the system in the 2-step process is approximately. So in this question what we have to find, that amount of heat supplied to the system in 2-step process, in which the first step is isobaric expansion and followed by an isochoric expansion, in which the relation PV to the power gamma equal to constant is given, for which P1 V1 and P2 V2 are given. So it is a adiabatic quasi-static process. So first of all we would like to draw the graph for this relation. So the graph should be like this. P and V. So it should be A to B followed by two process. First is isobaric, second is isochoric. So isochoric is this. So we can say this is going from A to B isobaric, B to C, that is isochoric. Now it is also given that is quasi-static. Quasi-static, static, adiabatic. Adiabatic. So we are going to calculate the heat supplied to the system. So we know that for adiabatic process, for adiabatic process, for adiabatic process, PV to the power gamma is equal to constant. Similarly, we are given P to the power 3, V to the power 5 is equal to constant. Similarly, we can write this relation as PV to the power 5 by 3 equal to constant. So we got the value of gamma is equal to 5 by 3, and this is equivalent to 1.67 or 1.66. This is for monoatomic. Now we are going to calculate heat supplied for process A to B and process B to C. Heat supplied for these two processes. Now we are going to calculate for process A to C. First of all, this one, quasi-static one. For process A to C, sorry. Okay, so process A to C, the heat supplied, that is equal to delta Q1. Delta Q1 is equal to NCP delta T. That should be equal to N, the relation of Cp and gamma, that is equal to 5 by 2R for monoatomic, into delta T. So it should be equal to 5 by 2 P delta V. Now we know that on placing the values of different terms, P delta V, change in volume, so 5 by 2 pressure is 10 to the power 5 into volume change 8 minus 1 into 10 to the power minus 3. Solving this, we got 1750 joule of energy supplied to the system. Similarly, we are going to calculate for process C to A to B, B to C. Now we are going to calculate for dq, heat supply, that is at constant volume. So we know that according to first law of thermodynamics, delta Q is equal to U plus P delta V. At constant volume, work done is 0. So heat supplied is equal to change in internal energy, that should be equal to NCV delta T. On placing the values, N into 3 by 2 into R for monatomic into delta T is usually this quantity is equal to 3 by 2 delta P into V. So we got delta Q is equal to 3 by 2 into 8 into 10 to the power minus 3 minus plus 1 upon 32 into 10 into 10 to the power 5. So solving this mechanism, finally we got delta Q is equal to minus 93 by 8 into 10 to the power 2. That should be equal to negative of 1.625 into 10 to the power 2. And this we got Q net. Q net is heat supplied, heat given and heat absorbed. So that should be equal to delta Q1 minus delta Q2, because Q2 is negative, we calculated. On placing the values of these two terms, we got 1750 is the heat supplied at constant pressure minus heat supplied at constant volume, but that comes to be negative. So that is 1162, and finally we got it around 588.7, 588.20 approximately. On round figure we got it 588 joule. So this is the final answer from this question. And in this question is quite easy also, in which we use to process isochoric and isobaric, where the concept of heat supplied is used. Question 6. Question 6. A small object is placed 50 cm to the left of a thin convex lens of focal length 30 cm. A convex spherical mirror of radius of curvature 100 cm is placed to the right of the lens at a distance of 50 cm. The mirror is tilted such that axis of mirror is at an angle of 30 degree to the axis of the lens, as shown in the figure. If the origin of the coordinate system is taken to be at the center of the lens, so coordinate of the point xy at these are at the positions. So we would like to write the option A are 25 and 25 root 3, option B 0 and 0, option C that is 125 by 3 and 25 root 3, option C D is equal to 50 minus 20, 50, it is 50 minus 20 root 3, that is 50 minus 25 root 3, and that is 25. Now this question is moderate, not an easy one, and in this question we are given two optical device, one is lens, another is mirror. The main concept in this question is mirror is tilted 30 degree with the horizontal axis. So definitely the final image formed would be different and its magnification would be different. So we have to calculate the coordinates of the point xy at which the final image is formed. So in this question we would like to draw the diagram like this, or we can say that if we consider a ray diagram for this part, rays coming, it will bend, it will strike and return back to the space. So finally we can say this is about to form image at this point, and now this is the final locations where the image will formed. Now in this question we are given 2 points. First of all, this is my first of all we will calculate the image formed from the lens L1. Now we will use the lens formula for this, that is equal to 1 upon u minus 1 upon v, 1 upon v minus 1 upon u, we can take it, that should be equal to 1 upon focal length. So from this part when we put the values, 1 upon f is equal to 1 upon v minus 1 upon u, and the focal length of the first is given as 30 centimeter. So we will placing that 1 upon 30 is equal to 1 upon v minus of 1 upon 50. Solving this one we got v is equal to 75 centimeter. So image will be at 75 centimeter at this point, but we are given the distance between mirror and image as 50 centimeter. So we can say the image I1 will be beyond 25 centimeter of the mirror we are given. Now this image I1 will behave as object length for mirror we have, and the final image let it framed over here. But we know that when the axis, if we consider it's like that, when we can say the axis of the mirror is placed in the axis of the lens, so from this part we can say they would like to merge strike, and they would like to merge strike, okay, and they will just, or they will form image at these positions. But whenever we are given, when the mirror is rotated by angle theta, the image will rotate by angle twice of theta. So we can say this, let the separation is 50 centimeter as it is given, and we know that let this image I1, it is at a distance x, so this distance will be equal to 50 minus x, and it confirm how much angle, this is equal to 60 degree, because we know that when the mirror is rotated by 30 degree, when the mirror is rotated by 30 degree, our image would be rotated by 60 degree, and this is the final location of our image, and its height we can say that is equal to y. So we are going to do some mechanism this time, that is equal to tan of 60 is equal to image length upon the distance we have 50 minus x, that should be equal to, solving this we got y is equal to 50 root 3 minus root of 3x. So we got y plus under root of 3x is equal to 50 root 3. Now we will check option 1 or option 2, because we are given an equation 1. If we put x is equal to 25 and y is equal to 25 root 3, So we got x root 25 root 3, y as 25 root 3 is to be 50 root 3. So we can say option A is correct. Now we will check option B. If we put x is equal to 0, y equal to 0 from this part, so it is not the right answer. Now we will put option C this time. Option C is given as 125 by root 3 and 25 by root 3. So we know that this also it not satisfy this relation. Okay, now we will check option C. Option C is 125 by 3 and 25 by root 3. On placing this value, so we got option A and C satisfied, but this is a single correct question, so there should one option would be correct. Now we will check out how can say, as option A and option C may be correct, but we need to choose only one. So how will we satisfy? We know that A and B both options satisfying, because size of image should be greater than size of object. So from that graph we are knowing that size of image, okay, or distance of image from the lens, from the mirror, that is y square plus 50 minus x whole square into sine 30 should be greater than 25 sine 30. Why we are taking it 25 sine 30? It's like that because image I1 will frame this side, so I will rotate it little bit, so this distance is how much? 25 sine of 30, and this would be equal to the distance we are calculating, that is equal to z. So we know that for this part the z should be greater than 25 sine 30. Solving this one, we got that y square plus x square. So we will take the value coordinates of x and y. From option A we are given 25 and 25 root 3. When we place this, we got, as it does not satisfy, okay, so it is wrong. As we check option B, that was already wrong. Now we will check for option C. Option C was given as in this question, that is 125 by 3 and root 3. So on placing these values, 125 by 3 and 25 root 3, so placing these values in terms of x and y, we got LHS is greater than RHS. So from these two given equations, we will check the correctness of all the options, and only all option B satisfy the answer. Hence we can say option B is the correct choice. Option B, and that is option B, option A, not sorry, option B, option A, that is option A, that is 25 and 25 root 3. So this is the correct choice of this question. So this question was quite difficult, or we can say moderate,